Welcome! In this video, we will get started with the bank loan data. In a first step, we will download the bank loan data and open it together. After that, we will get to know the data. That means we will open it and we will identify which variables are the identification variables, the y variable of interest, and the x variables. The y variable is the variable we are trying to predict, and the x variables are our labels, which we try to use in order to predict the y variable. After that, we will check our dataset, which variables are factor variables and which of our variables are numeric variables. The difference is that factor variables have many different kinds of levels. These levels are usually coded as a string. That means they contain letters from the alphabet. Numeric variables usually are just numbers. But beware, sometimes factor variables can be coded as numeric variables. Think, for example, if a data scientist wants to code the days of the week. He could simply give Monday the value of 1, Tuesday the value of 2, and so on until Sunday a value of 7. These numeric values, of course, don't have any interpretation beyond just indicating what day of week it is. So Sunday with a value of 7 minus Friday with a value of 5, of course, does not equal Tuesday with a value of 2. We will then continue to identify missing values. This is a huge problem in empirical analysis and has to be dealt with accordingly. Else the whole analysis might give us very misleading results. Afterwards, we will also identify duplicated rows. Let us begin with our bank loan case. Let us suppose you are the only data scientist for the HSG Bank. Now your colleague from the IT department exported the huge dataset combining data from various systems in the HSG Bank. This dataset, on the one hand, reflects past customers, so it gives a lot of information about what kind of customers the HSG Bank had in the past. For example, there are variables about their past income, what the purpose of the loan was, or how big the loan was. On the other hand, the dataset also contains information on whether or not the loan was actually paid back. Now, we acquired this data from the IT department because the chief risk officer of the HSG Bank, he came to us and tasked us with building a predictive model that can identify whether or not prospective future clients will be able to pay back the loan or not. We can try to tackle this problem by checking in our data whether we find any patterns which distinguishes people who can pay back the loan from people who cannot pay back the loan. Now let us download the data. We can click on the link here, more specifically, Control left click on the link, and then we will get to a website where there will be a folder named Bank Loans. At the end of the slide, I will show you how to do this. Now, there are a couple of different versions of the data in this folder. The original one, the raw one, which means just the unprocessed, the uncleaned data, which has a lot of weird stuff in it, like missing values or outliers. That one we will start with. The original one has a lot of different cases, like 260,000 cases, and it's named loan defaults underline original, and it's an Excel file. Now, that Excel file is quite large, so if you don't have a strong computer, I recommend that you download the smaller one, which had only 150 randomly selected cases from the original data. Note, however, that you will not be able to see the same patterns as we will look at in the future video. But it's okay if you just want to identify a couple of the problems associated with the data at hand and getting to know the data. Now, additionally, there's also the processed version of the data, which is called the cleaned or the processed loan default data. We will use that data in the next video, where we'll be talking about analyzing patterns with pivot tables. Finally, The same data is also saved in a comma-separated values format, a CSV format. We will use that one to import it into Microsoft Azure. Because when we import data into a statistical program, such as Microsoft Azure, it's much better to do so if it's in a CSV file format, because the computer is just much easier to be able to read it. It doesn't have that much ambiguity like if it would be just in Microsoft Excel, because the computer programmer can't read whether or not the cells are bold, there's cursive in it, or special formatting. It doesn't like that in data. It needs to be very standard. And that's why we usually work with comma-separated value format. Now let us open the link in order to get to the data. We do so by clicking on here. If you just got the presentation open without being in full screen mode, you will have to click Control first, keep it clicked, and do a left click. The link forwards us to the bank loans folder. We can click on it, and here we see the datasets which I just mentioned before. Now click on the loan defaults original Excel file, but don't click on the picture, click on the upper right. And now on the top, you can download it. Let us open the data below by double clicking it. Maybe it will appear in your downloads folder and you will have to go to that folder to open it. Please note, since this dataset is quite large, it will take quite some time to open it. If you'll not be able to open it, then just open the small one with 150 randomly selected cases. We will now need to enable the editing function. We now open the data. I recommend that you pause the video and that you take a couple of minutes of time and that you check for yourself first what you can observe in the data, what do you see in the data, what makes you curious, are there any particular features that you think don't make sense? Can you identify the identification variables? There are two. Do you know which variable is the y variable, which we want to predict, and what are the x variables? Now let us start discussing the data. First of all, we have the first two columns. The first one is loan ID, which is a unique identifier for each loan given by the HSG Bank. This should be unique. Doesn't make sense that there are two loans exactly the same. The second column is just a unique identifier for the customer. Each customer has a unique identifier. Now, the third column is called loan status, and it is 0 if he paid back the loan, and it is 1 if the customer of the HSG Bank defaulted. So this is our y variable of interest, which we try to predict. All the other columns here, we have the current loan amount, the term, the credit score, years in current job, home ownership, annual income, purpose, monthly debt, years of credit history, and so on. These are x variables. We will use those to predict our y variable of interest. Now I think each one of you was able to recognize at first glance that in the current loan amount variable we have a very long number. So 8 times a 9. This is really, really big, and in comparison to the other numbers it doesn't make any sense, right? It's obviously much too big and we have quite a couple. So what is quite common in data analysis is that data scientists, they just put in a really high number or maybe even a negative number to indicate that it's actually a missing value. What we also see is here in the annual income, we also have missing values indicated by an NA. We also have them in the credit score. It's also an NA, right? And in the variable next to it, in years in current job, we have an NA value that is specified with N/A. Now, why do we have all these different kind of missing values? Why can't they just use one indication for all of them? Now, this is quite common in business because many variables, they are just from different systems, right? And they are just all pulled together and combined, for example, by the IT administrator from our data warehouse. And that's why we have many different kinds of types of missing variables. So what do we do with these missing variables, with the N/A, with the NA in caps, and with the long 9999? What I suggest you to do is just to replace all these values with a blank. So that just means you double click the variable and you just delete it, right? Now, obviously you can just do this quicker by, for instance, in the current loan amount variable, by hitting Ctrl and F, clicking on replace. Now we type in 8 times a 9. And we replace it with nothing. And we click replace all. Now you see, we had quite some replacements, over 35,000. If we would not have done this, this would have totally gave us a wrong analysis. We can do so also for the NA here and for the NA which was written in a different format, which we already put in a blank. Now there are quite some more, and that's why I recommend that you always do it with a Ctrl F and replace all. Now I recommended to you that you should fill in the missing values just with a simple blank. Why did I say this? Because most computer programs, statistical programs, they will automatically recognize a blank as a missing value and code it accordingly. This will save you a lot of trouble, because sometimes an NA in your data will turn the whole variable into something weird because it has alphabetic letters in a numeric variable. You don't want that. Now, what will the computer do with a missing value? If you don't do anything, it will simply omit it, the whole row of observations, because it cannot model missing values. Now, that is the first option, is simply omit them. As a second option, you can replace the missing value with either, for example, the mean, the median, or the mode, and just place the mean of the, for example, the credit score variable, and you fill that in for the missing values. That is one option you could do. The third option is you could impute them. Now there are some algorithms which impute the data, for example, mice, and they will do so by taking into consideration all the other covariates, and they will find reasonable values for the missing values of your variable based on all the other x values. Now, when you have missing values, you always need to question, are these missing values random? Because consider, for example, the annual income variable. Maybe really high income earning people, they do not want to disclose to the HSG bank how high their income really is. And that's why there's a missing value here. Now, how can we take this into account? Now, a common practice is that you could make a new variable. That means here in this data set, you enter a new column that is 1 for each entry here that has a missing value. So you could make here a new column. Now it's on the left-hand side, so that equals 1 for each missing value of the annual income variable. If we observe the value, it will be 0. And we would do this for all these entries of the annual income variable. What this does is that we still know if the variable was missing or not. We don't lose this information. We could potentially have a high income earner. And now we would just replace this with another value so as to not lose the whole observation, because the algorithm, it cannot take missing values into account. So usually you just replace this now with a mean or a mode or the median value. Now let us proceed with the purpose variable. If you check the purpose variable, you will notice that there is one level of this factor variable, which is called other, and it is written small. And now, if we scroll down, we see that we have a different entry. This is also called other, but other is written with the first letter in caps. This is a big issue. If we do not correct for this, the algorithm which we use will think that these two entries are different, even though they're actually the same. Let us proceed with the variable on the right. Now in the monthly debt variable, you see all these dollar signs in the preceding the numbers, right? This is also a big problem for statistical programs. There cannot be any special character inside the numeric value. It will read it wrong and give you really weird results. That's why we need to remove the dollar sign in all the entries of the variable of monthly debt. Now, if we continue on with the variable months since last delinquent, that's the variable here, we see, if we scroll through, that there is an incredible number of missing values. This is a big problem because we cannot treat it accordingly to the prior introduced methods of treating missing values, because there's simply too many. If we would, for instance, just simply omit them, our sample size would be reduced significantly, which would not allow us to do the same kind of analysis with the same kind of results, because we simply do not have enough data. So what can we do? A common practice is just to omit this variable, because it doesn't have much information in it anyway, right? Because it has so many missing values. And imputing all these values would not make really sense, because the information is already contained in the other x variables. So I would suggest, if we want to try to model whether or not the customer will be able to pay back his loan, we exclude this variable. Now, we already briefly discussed the two identification variables, namely the loan ID variable and the customer ID variable, and what they are good for. In particular, they are good for identifying duplicate values. Duplicate values refers to that we have two rows which contain exactly the same information. But in some rows, the row is faulty. Now just compare rows number 8 and 9. What we see here is that the loan ID is exactly the same in the top. You can just compare them. We also see that it's from exactly the same customer, but we see that in the row there are missing values. But on top, the values, we observe them. What we further see is that something here in the credit score doesn't make sense, because here the credit score is extremely large. And if we compare it with other credit scores, this doesn't make sense. So what I think is going on is that we have, just at the end, we have a 0 too much. So we would just need to remove this 0. Furthermore, this row here, row 9, it is simply a duplicate and doesn't contain all the information that row 8 contains. So what we need to do is, we need to remove row 9, we need to delete this row, and we need to adapt a correct credit score, which we think is just a mistake by having a 0 too much. Now, how can we identify all unique rows, or whether or not they are duplicates? We can simply do this by selecting the loan ID column and going on the Home tab, clicking on Conditional Formatting, highlight Cells Rules, and Duplicate Values. Click on OK, and this will highlight in red the cells which contain duplicate values. Now you can check this for yourself, but these mostly are just simply duplicate values, and we need to remove either one row of them. Like I said before, if one row contains missing values, the other row doesn't, we need to, of course, delete that row that contains missing values and keep the other one which doesn't. And if there's something wrong with the credit score, we need to remove that extra zero, else it will give us big mistakes in the prediction. Now, how can you just select all these red cells? You can simply do this. If you don't want to scroll and check everyone manually like I'm doing now, is quite a lot, because there are over 250,000 rows. So what we can do, we can right click, filter, and click on Filter by Selected Cells color. What this will do, it will give you a list. So it will just give you those rows which are pink. And then you can check them row by row and decide which one to delete and which one to keep. I am not going to do this here because depending on your computer, it takes a significant amount of time because we are working with such a huge data set. We will do this for you in the processed data set, which I already talked about. And we will use that processed data set next to do some pivot tables. Now, I already talked briefly about factor versus numeric variables. Which variables in our dataset are factor variables? In particular, this is the term variable. Years in current job. You see this has also quite a particular format. This indicates that it's a factor variable, and it will also take quite some time to clean it. Home ownership, we also see, has various levels. Some levels being home mortgage, own home, renting. Those are the levels. We also have the purpose of the loan. This can be debt consolidation, business loan, or home improvements, and some other levels such as to buy a house. Now, before we conclude this video, let us consider this quick checklist for cleaning data. We always need to check the data, and we need to identify which are my y and my x variables. Furthermore, if we have any identification variables, we also need to check whether or not we have any duplicated rows. As we just saw, this is quite important. Furthermore, we need to consider any missing values. We do so simply by scrolling through our variables and seeing if we have any obvious outliers, like a really, really long number or low number. The other option is that they're coded as a string, so with alphabetic letters, such as NA or simply a blank. We also need to consider whether or not there are inconsistencies in the coding of factor variables, as we saw with the example of other and other. And we also need to check, in particular our numeric variables, whether or not there are any special characters, such as a $sign. Thank you very much for watching.